All right, welcome to Notes 3.12, and in these notes today we're going to talk a whole bunch about lines, specifically parallel lines, and the angles that they form. So we're going to begin, as always, with a bunch of vocabulary. Parallel lines we're all familiar with. Here's the actual definition: coplanar lines that do not intersect. This word coplanar is very important. It means that they lie within the same plane, and that's what differentiates them from skew lines. Skew lines are non-coplanar lines that do not intersect. So they do not lie in the same plane, and yet they do not intersect. I want you to think a bit about skew lines, and I want you to come up with a really good example of a pair of skew lines for the notes check. All right, parallel planes. Parallel planes are two planes that do not intersect. So, for example, the floor of the room that you're sitting in right now and the ceiling of the room that you're sitting in right now, assuming that they were built correctly and they are both level, then those are two planes that do not intersect. My personal favorite example of parallel planes are the ends of my soda can. You guys know how obsessed I am with Coke Zero. Well, the top and the bottom of my soda can are circles, and they lie in parallel planes. And they are what makes it possible for me to have 12 satisfying ounces of Coke Zero. All right, let's talk about transversal. A transversal is a line that intersects two or more coplanar lines at different points. So let's see what that would look like. Picture's worth 1,000 words, right? So I've got a line, I've got another line, and then I've got my transversal. So the two black lines are my coplanar lines, and the red is my transversal because it intersects both of them at different points. All right, let's talk about some angle pairs or angles that are formed by two lines, two coplanar lines, and their transversal. So the first one I want to talk about are corresponding angles. And corresponding angles are two angles formed by two coplanar lines and a transversal that occupy corresponding positions. Corresponding. Okay, so let's give another example here. So here I've got two lines in a plane. This time my transversal is going to be the black line. Okay, and you have to imagine that we're talking about, let's say, for example, an intersection. So if I'm driving my car up this road and I stop here at the traffic light, and then I drive further up the road and I get to the next intersection, I'm going to stop in the same place relative to that intersection. So these two purple angles right here, those are my corresponding angles. They occupy corresponding positions, bottom right of the four angles at the intersection. Okay, moving on to alternate interior angles. Alternate interior angles are two angles formed by two coplanar lines and a transversal that lie between the two lines and on opposite sides of the transversal. So you can kind of get a clue from the name. Alternate indicates that they are going to be on opposite sides of the transversal, and interior means that they are going to be between the two lines. So to go to my example up here, let's go ahead and use blue for this. If I want to talk about alternate interior angles, they're going to be on opposite sides of the transversal. So for example, this angle right here and this angle right here, and between the two lines. All right, and then we have alternate exterior angles. So alternate exterior angles are two angles formed by two coplanar lines and a transversal that lie outside the two lines and on opposite sides of the transversal. So again, we have that word alternate, meaning opposite sides of the transversal, but this time we have exterior going on. And exterior means that it's going to be outside the two lines. So, for example, this angle right here and this angle right here. They are outside the two lines, which makes them exterior, and they are on opposite sides, one's to the left, one's to the right of the transversal, which makes them alternate, so alternate exterior angles. And then our final angle pair is going to be consecutive interior angles. And my consecutive interior angles are two angles formed by two coplanar lines and a transversal that lie between the two lines and on the same side of the transversal. So you'll sometimes also hear them called same side interior angles. I prefer consecutive interior, but they're both the same thing. So they are on the same side of the transversal. That's what my consecutive tells me. Consecutive tells me they are on the same side, also same side. And then they are inside. The interior tells me that they are between the two lines. And I think my my diagram up here is pretty crowded now, but we're basically talking about, for example, this angle right here and this one right here. So in between the two lines and on the same side, these are both on the left-hand side of the transversal. All right, I need you to be very clear on the names of all these because they're going to become very important. One thing I do want to point out is that these angles have these names regardless of whether these two lines are parallel or not. We're about to learn a whole bunch of stuff about what happens when these two lines are parallel and how these angles are related, but these names hold true even if the lines are not parallel. Very important concepts. So we've got these postulates. They have numbers. We are not going to use the numbers. We are going to simply talk about what they mean. And the parallel postulate tells me if I have a line and a point not on that line, so if I have line L here, and then I've got point P that is not on line L, then there is exactly one line through P parallel to L, exactly one line that goes through P that is parallel to L. My perpendicular postulate tells me something very similar. If I have a line, again line L, and a point P that is not on that line, then there is exactly one line through that point that is going to be perpendicular to the given line. Okay, so let's see how well we've learned our vocabulary. I need to find a line that is parallel to MN here and contains point J. If you said JL, you are correct. I need to find a line that is skew to MN and contains J. Well, remember, skew means non-coplanar, so it can't be in the same plane as MN, and it's got to contain J. So if I were to pick JL, well, JL is in the same plane. This is my plane right here as MN. Although they do not intersect, which is part of skew, they are coplanar, which is not part of skew, which means that the line that I must be talking about must be line JK. All right, and then I need one that is perpendicular to MN and contains J. All right, I hate this question, and here's why. Because we don't see this, right? And we can't tell that two things are perpendicular unless we're specifically told to. Fortunately for us, God has come down from heaven above and has told us that these right here are right angles, which means that we can now say that JN is perpendicular to MN. And we need to name a plane that contains point J and appears to be parallel to MNO. Now, this appears to be, I'm okay with. Makes my life a little easier. And so that would be plane JKL, because these two appear to be parallel planes. All right, moving on to our next practice assignment. I believe that what I have and what you have are a little bit different, but what I would like you to do is go off of the information that I've got sitting here in my notes and find for me segments or lines or planes that fit this description here in my diagram. And once you've done that, I want you to come back and check and see if you got the right answer. So hit pause. All right, so this is what you should have gotten. You should have gotten line EJ for A. And then for B, I would accept pretty much anything. DE is the most obvious because it's actually shown to be a line in your diagram. But I would not accept EJ for sure. All right, but pretty much any other set of points would be okay with me as long as one of them was E. All right, again, I've got a problem with this, so I've written an appearing here. and the point that appears to be perpendicular to AF that contains point E is AE. And then finally, my plane parallel to FGH containing point E, it's got to be some three-letter combination of this plane right here. So ABE, ABC, BCD, CDE, whatever you want, as long as you pick three letters that are contained in this pentagon right here. All right, good. Okay, so we have a diagram here, and we need to answer the following questions. We need to name a pair of parallel lines. I can't remember if we've ever talked about this or not, so I'm going to talk about it right now. But this marking right here, this little arrow on the interior of my line, that indicates that those two lines are parallel. That is how we mark parallel. So that means we do in fact have a pair of parallel lines. We know that AB is parallel to CD. All right, and then we need to name a pair of perpendicular lines, and because we've got our little box right here, we know that line AC is perpendicular to line AB. All right, and then it asks us, is AC perpendicular to CD? Well, it's not drawn in here. However, we know that in this diagram, because we're not shown otherwise, that these are all coplanar. And so if I have two lines that are parallel, and I've got a line that's perpendicular to one of them, it must also be perpendicular to the other one. So we can say that yes, those two lines are perpendicular. In this page, we're going to see exactly how well you paid attention to the vocabulary. So what I need you to do is go ahead and fill in all of this information based on the vocabulary we learned at the beginning of this unit, and then come back and check your answers once you're done. So hit pause, and I'll see you with your answers. Okay, so you should have gotten corresponding for this first pair of angles because they are in the same position relative to the intersection, and we abbreviate corresponding by just saying CORR. And then the next pair of angles, because they are between the two lines and on opposite sides of the transversal, they are alternate interior angles, and we abbreviate that as alt-int. And then likewise, opposite sides outside the two lines, so these are alt-ext. And finally, same side of the transversal inside the two lines, so these are consecutive interior, which are also known as same side interior angles. Okay, what I need you to do on this slide is I need you to find some angle pairs, alternate interior, alternate exterior, corresponding, same side, and vertical angles. So give me a bunch of angle pairs, and then once you've got your answers, come back and check and see if they are correct. So hit pause. All right, well, obviously there are a bunch of each of these angles, so I've just given you some sample angles. Alternate interior angles are any angles that are on opposite sides of transversal and in between the two lines. So for example, 3 and 10, or 12 and 13, or 2 and 7. Okay? And then my alternate exterior angles are outside of the two lines and on opposite sides of the transversals. So for example, 1 and 12, or 3 and 6, or 9 and 16, but obviously there are a lot more than that. My corresponding angles are in the same position relative to the intersection. So 1 and 5 would be an example, 3 and 11 would be an example, 8 and 16 would be an example, and obviously there are many more. Same side interior angles are between the two lines and on the same side of the transversal, so 4 and 7 are an example, 3 and 9 are an example, 12 and 15, and so on. And then my vertical angles, again, I have lots of pairs of vertical angles, but 1 and 4 are an example, 7 and 6, and 13 and 16. If you are confused about any of those, then please make sure to ask me in class tomorrow. All right, when we were learning vocabulary, I made kind of a big deal out of the fact that those names were true, corresponding, alternate interior, alternate exterior, regardless of whether or not the lines were parallel. But now, if we add into the statement that parallel lines exist, and are cut by a transversal, then that makes something true about the kinds of angle pairs. So for example, with my corresponding angles postulate states if I have two parallel lines cut by a transversal, then the pairs of corresponding angles are congruent. And we're going to be using this a lot in proofs, and obviously we don't want to have to write all of this out, so I have a little shortcut. So basically you're going to write if parallel, then corresponding angles are congruent. All right, so that's going to be your shorthand. You're not going to write the corresponding angles postulate, and you're not going to write all of this out. You're just going to write this. All right, so my alternate interior angles theorem states that if I have two parallel lines cut by transversal, then the pairs of alternate interior angles are also congruent. All right, and the shorthand for this would be if my lines are parallel, then alt int angles are congruent. Okay, moving on to my alternate exterior angles theorem. Again, two parallel lines cut by a transversal, then my alternate exterior angles are also congruent. And the shorthand, if parallel, then alt ext angles congruent. All right, and then finally my consecutive interior angles theorem states if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are not congruent. This time we're talking supplementary. Okay, so the first three are congruent, but the consecutive interior angles are different because they are supplementary. So my shorthand for this would be if parallel, then, that's an N by the way, consec int angles sup. I always feel like saying dude after that, but I will restrain myself. All right, so if parallel, then my consecutive interior angles are supplementary. You're going to need to memorize all of these. Okay, let's go ahead and use those postulates and theorems that we just talked about to find the measures of some angles. So I know that the measure of angle 7 is 75 degrees. Well, the measure of angle 1, what kind of angles are 1 and 7? They are alternate exterior angles, which means that they are congruent. So the measure of angle 1 is also 75 degrees. And that was because if my lines are parallel, then alt ext angles congruent. All right, let's talk about angle 3. How is angle 3 related to angle 7? Those are corresponding angles. And if my lines are parallel, then my corresponding angles are congruent, which means that the measure of angle 3 is also 75 degrees. So if parallel, then corresponding angles are congruent. All right, and then finally, angle 5. Well, what kind of angle is 5 in relation to 7? It is a vertical angle, and we know that according to our vertical angles postulate, that vertical angles are congruent. So, do we need to state if lines are parallel here? No, we don't, because vertical angles are congruent regardless of whether my lines are parallel. So we can just say that vertical angles are congruent, or you can write the vertical angles postulate. But this is better because it explains that you know what the vertical angles postulate is. Okay, so in this case we need to find the value of x. Well, these two angles are what kind of angles? Alternate exterior angles. And if my lines are parallel, which they are because the little arrows here, then my alt exterior angles are congruent. So I can just set these two equal to each other and solve. 113 equals 3x minus 4. Solve for x, please. I am sure that you got that x equals 39. Good job. What I want you to do is I want you to go to the notes check, and I want you to refer back to this diagram here. And I'm going to need you to tell me which three angles also measure 125 degrees, and I need you to give me a justification for it that relates back to this original 125-degree angle right here. So how each of the angles that equals 125 is related to this angle. And that will be part of your notes check. All right, if you have any questions over anything that we've covered in Notes 3.12, be sure you have them ready to talk about when we get together in class. Thanks.